Good afternoon, friends. Today we are going to provide the video lecture on the radio wave propagation, its initials or its beginning. Student friends, up till now, when we studied the topic number 3, that is antenna and radio wave propagation, almost all we have covered the entire topic. Within that, we have to deal with introductory aspect regarding the radio wave propagation. We are well aware that if the transmitting antenna is located to the transmitting end, receiving antenna is located to the receiving end, when transmitter transmits the modulated high frequency radio frequency signal which is provided to the transmitting antenna, that converts this radio frequency signal into electromagnetic radiation, and then this electrical energy which is escaped from the transmitting antenna will start traveling from transmitter toward the receiver in a space through the several paths of propagation, and finally reaches to the receiving antenna. The receiving antenna converts the electromagnetic signal into the radio frequency signal and is coupled to the receiver or destination. Friends, we have studied the transmitting antenna, we studied the receiving antenna. In between transmitting antenna and receiving antenna, how the energy containing the signal information in the form of electromagnetic wave in nature travels in space through the atmosphere, and this motion of carrying the signal information in the form of electromagnetic radiation between transmitting antenna and receiving antenna, it is called as radio wave propagation. We are introducing the same today. Dear students, the electrical energy which is escaped from the transmitting antenna in a free space in the form of electromagnetic waves, that is known as radio waves, means the signal which is transmitted from the transmitting antenna into the space, that is known as electromagnetic wave, carries the energy, and that's what it is called as the radio wave. In short, the electrical energy that escapes in a free space in the form of electromagnetic waves is known as radio wave. This radio wave contains half electrical energy or electric field and half magnetic field at right angle to each other, and this propagation is at right angle to the propagation of the electric as well as the magnetic energy. Means in short we can say the electrical energy which is escaped in a free space containing radio frequency signal is called as the radio wave. This radio wave contains 50% electrical energy, 50% magnetic energy. Both the energies are at right angle to each other. They combinedly travel along the direction perpendicular to the direction of electric as well as the magnetic field. This is represented by the right hand rule. So here it represents on y-axis there is direction of propagation of the radio wave. On x-axis there is an electric field. On z-axis there is a magnetic field intensity. So this is the direction of electric field. This is the direction of magnetic field. Both are at right angle. This is the plane of propagation and plane in which the signal resides, and it will propagate at an angle, right angle to the electric field as well as the magnetic field that is represented here. So that's what it is called as the right hand rule. So this is the right hand rule. Friends, if this is the direction of resultant, that is propagation of direction of the radio containing electric field as well as a magnetic field, this is the direction of electric field, whereas this is the direction of magnetic field. So right hand rule we are considering, along this there is a resultant, that is electric field as well as magnetic field. Along this direction there is only electric field. At exactly right angle there exists a magnetic field. When you close your hand, both will travel along the direction of the electric as well as the magnetic field. This is the right hand rule. Accordingly, the existence of electric field and magnetic field in a particular plane traveling perpendicular to the direction of electric as well as the magnetic field. Thus we can say the electrical energy that escapes in a free space in the form of electromagnetic radiation carrying the radio frequency signal from transmitting antenna towards the receiving antenna, that is known as the radio wave propagation. Let us proceed further. Let us going to see some definition related with the radio wave propagation. The first one is the plane in which the electric field resides is known as plane of polarization. It is actually three-dimensional structure, and within that the electrical field resides in a particular plane. That plane is known as plane of polarization. If electrical field is in a vertical plane, the wave is vertically polarized. And if the electric field is in a horizontal plane, then radio wave is horizontally polarized. When the radio wave is horizontally polarized, almost all vertical components are grounded. And when the wave is vertically polarized, almost all horizontal components are grounded. A plane which is parallel to, mutually perpendicular to electric and magnetic field, it is called as the wavefront. The wave travels normal to the wavefront. The plane which is parallel to mutually perpendicular electric and magnetic field. If you look at here, so this is the electric field, this is the magnetic field, and this is the plane which is perpendicular to both. This is what we can call it as, it is the wavefront. Friends, the wave which is radiated from transmitting antenna reaches to the receiving antenna by traveling through the several paths of propagation. Now, just by knowing the meaning of radio wave, what exactly it contains, and why it is called as radio wave propagation, how it is used to carry the radio frequency signal from transmitting antenna towards the receiving antenna. Now we are going to study the types of radio waves which are used to carry the radio frequency signal from transmitting antenna towards the receiving antenna. The wave which is radiated from transmitting antenna reaches to the receiving antenna through the several paths of propagation. Those several paths of propagation are called as types of radio waves. The first one is the radio wave that carries the energy from transmitter towards the receiver. After reflection from ionosphere, it is called as sky wave. If transmitting antenna has a high power, if it is a high frequency radiating transmitter, then the electromagnetic energy escaped from the transmitting antenna will reaches to the much more height in a space, travels towards the ionosphere. From that, it is reflected back towards the receiving antenna on the earth. Such a wave that carries the radio frequency signal, it is called as sky wave propagation. This is one of the type of the wave that is used to carry the radio frequency signal that reaches maximum height around about 300 km above the earth's surface, where the ionospheric layer is going to be located. Through that, after reflection, if it carries the energy towards the receiver on the earth, such a wave that covers very large distance, and that is known as the sky wave. A wave that reaches the receiving antenna after reflection from troposphere is called as tropospheric wave. Tropospheric layer is at a height of 10 km above the Earth's surface below the ionosphere. And if the wave only reaches to the troposphere, and from that, if it reflects or refracts and carries the energy, such a type of the wave we can call it as it is a tropospheric wave. This is the second type of the wave that is used to carry the signal information between transmitting and receiving antenna. It covers a less distance. Then a part of energy that travels in a line of sight from transmitting antenna to the receiving antenna is known as direct wave. The wave that escapes from the transmitting antenna without being reflection, even from the ionosphere or troposphere, or even from the Earth's surface, it will not reflect, directly goes to the transmitting antenna. It is called as the direct wave. That is used for line of sight of communication. This is the third type of the wave. The wave that travels after reflection from the ground is known as ground reflected wave. Some part of the energy that reaches to the Earth's surface, and after that it is reflected and then reaches to the receiving antenna, then that type of the wave we can call it as it is the ground reflected wave. There are some type of electromagnetic radiation that travels by touching to the Earth's surface. That is known as the surface wave. The combination of the direct wave and ground reflected wave are called as the space wave. This radio propagation takes place by sky wave, tropospheric wave, space wave containing the direct wave and ground reflected wave, and also the surface wave or ground waves that carries the energy by touching to the Earth's surface. These are the different types of the waves which are used for carrying the signal information between transmitting and receiving antenna in a space or in the atmosphere. The space wave comprises the direct wave and ground reflected wave. The surface wave propagates along the surface of the Earth. All these types of the waves are represented in this particular diagram. You look at here. So this is the Earth's surface which is represented by considering its curvature. Let me suppose here is a transmitting antenna that is represented by T. Here is a receiving antenna. In between that, the signal is expected to be communicated. If suppose the wave radiated from this particular transmitting antenna reaches to the ionosphere, which is much high, 300 km above the Earth's surface, from that, if it is reflected back towards the receiving antenna, this type of wave it is called as the sky wave. This propagation is possible provided the frequency is very large, that is in megahertz. You may ask the question, what happens above this? If energy escapes the ionospheric layer, then that is used for satellite communication, and those waves are called known as the microwaves. Means one of the type of the wave that reaches to the ionosphere, after reflection it carries the energy to the receiver on the Earth's surface. That is used for long distance communication, for high frequency communication. These waves are called as the sky waves. There are some radiations that travel only up to the troposphere. From the troposphere, it will be reflected back. So this takes place within 10 to 12 km above the Earth's surface. That is known as a tropospheric communication. So tropospheric waves are another wave. Those are used for carrying the signal between transmitting antenna and also the receiving antenna. There are some of the waves which will be escaped from the transmitting antenna reaches directly to the receiving antenna. These are used for line of sight of communication. It is called as the direct wave. There are some of the electromagnetic radiations which will be escaped from the transmitting antenna reaches to the Earth's surface, and from Earth's surface they are reflected back towards the receiving antenna. So this it is known as ground reflected waves or indirect waves. The combination of the direct wave and ground reflected wave are called as the space wave. There are some of the radiations that travels by touching to the Earth's surface between transmitting and receiving antenna. So that is called as the surface waves, or those are also called as the ground waves. Friends, the propagation of the radio wave thus takes place by using ground waves, surface waves, ground reflected waves, direct waves, tropospheric waves, and also by means of sky waves. So these are the different types of the waves which are used to carry the signal information between transmitting antenna and receiving antenna. Depends upon the distance between transmitting and receiving antenna, depends upon height at which the radiations are going to reach. This depends upon the power of the transmitter and also the frequency of the transmitter, which may decide which kind of the wave are possible to carry the signal from transmitting antenna towards the receiving antenna. The propagation is also going to depends upon time schedule, time to time, day to day, season to season, condition of the atmosphere, condition of the space. All these factors are going to affect the entire radio propagation. Even though it is true, the communication is taking place. Friends, that's all about the one of the lecture associated with the introductory aspect of radio wave communication and its types. Next time we'll go for such next lecture.